In this tutorial, I'm going to show you how to solve more rational equations that are a little bit more difficult. So let's go ahead and jump right in and get started. Alright, so here's our first problem. And the reason that this is a little bit more difficult is because I have two rational expressions that are being added or subtracted, in this case subtracted. So I can't just go in and cross multiply. I have to do a little bit more. So the method that we're going to use here, if you happen to have more than one rational expression and the denominators are not the same, we want to find the least common multiple that both of those numbers go into and use that to help me change the way that my fractions look. So what I want to walk you through is to discuss what 2 and 5 both go into. And the answer to that question is 10, right? So I'm just going to write that out here for right now. Also, if there happens to be an x in the denominator, either here or both places, you want to automatically use that when you simplify the way that this looks. Because we don't want x's left in the denominator no matter what. It just creates a little bit more difficulty. Not that it's impossible, but let's try to make this as simple as possible. So here's what I'm going to do. I'm going to take 10x and I'm going to multiply that by each of my fractions. And I'm going to show you why and exactly how that helps us. So I am going to do 10x times 1 over 2x. Now keep in mind 10x is the same thing as 10x over 1. So when I multiply that by 1 over 2x, I get 10x divided by 2x. And I hope that right now you can see that that will simplify, but I'm not going to touch that right now. Alright, the next fraction, there's my minus sign, so 2 times 10x is 20x, and 5x times 1 is 5x, equals 10x times 1, 10x, 1 times 2 is 2. Okay, so once you do that, what we're going to do is we're going to go through each fraction individually and simplify. So 10x divided by 2x. Well, the x's are going to cancel, and 10 divided by 2 is 5. Minus. Alright, the second fraction, the x's will cancel. 20 divided by 5 is 4. And in the last fraction, the x is going to stay there, but 10 divided by 2 is 5. So that's going to result in 5x. Alright, so let's simplify this and solve. 5 minus 4 is 1, and that's equal to 5x. So my last step here is to divide both sides by x. Therefore, my solution is 1/5. So there you go. That's the more challenging kinds of problem. Let's do another one. Okay, here we go. So the first thing that we got to do is figure out what the least common multiple is. So notice I have an x in the denominator, so I'm going to use that for my least common multiple. I also have a 2 here. And the only other constant that I have down here is a coefficient, which is 1. So that's going to just leave me with a 2. Alright, so 1 and 2 both go into 2. The fraction on the right-hand side has 2x. Well, I already have both of those included in my least common multiple, so every single one of my denominators is covered. So now I have to go into each fraction and multiply these by 2x, and we'll see what happens. And by the way, if you're a little rusty on finding your least common multiples with terms like this, just be patient with yourself. If after you multiply this out, you start getting something uglier than you started with, chances are you did something wrong. So back up and try again. So let's see what we get here. 1 over x times 2x over 1 is going to be 2x over x. So here's a good way of checking to see if you got the correct least common multiple. Will the x in the denominator cancel out? And the answer is yes. So far, I'm good. Plus 2x times x is 2x squared over 2 times 1, which is 2. All right, so here, notice that there's not going to be any x's in the denominator, and the 2's are going to cancel, so that's going to be nice as well. All right, so 2x over 1 times x plus 4 divided by 2x. I'm just going to write it out like this without distributing, because I see that 2x is in the numerator and denominator, and therefore they're going to cancel. So if I were to distribute, it's not going to be so helpful because I know that they're going to cancel, and that just takes practice to see. So now it's time to reduce. So x's cancel, I'm left with 2. 2's cancel, I'm left with x squared. 2 x's cancel, I'm left with x plus 4. This is feeling like it's going to be a quadratic that I'm going to be able to factor for. So I'm going to leave x squared where it is. I'm going to move my x term over, so I would have to subtract it, so minus x. And then I would have to subtract 4 here, so that's going to give me 2 minus 4, which is negative 2, equals 0. All right. So now I'm going to set up my parentheses, x, x, and now I need factors of 2 that get me to 1, which is going to be minus 2 plus 1. So now I set each of these equal to 0. This one is going to give me the solution of positive 2. And this one is going to give me the solution of x equals negative 1. All right, I've got one more problem for you, and then we're going to be done. All right, here we go. So in this problem, we have to find our least common multiple. So the only coefficients that I have are 3, 3, and 1. So 3, 3, and 1 will all go into 3. All right, and I'm actually going to change color here. This is a little hard to see. There we go. All right, now I do have an x here, but I have x squared here. So you always want to use the larger of the amount of x's. So between x to the first and x squared, I'm going to use x squared. So that looks like it covers my x's and my coefficients. So now we're going to go in and multiply my fractions. Oops. There we go. All right, so this is 3x squared over 1. So 3x squared times 11 is 33x squared over 3x. All right. 1 times 3x squared is 3x squared. 1 times 3 is 3. And 3x squared times negative 4x is negative 12x squared, and 1 times x squared is x squared. All right, so now it's just time to reduce and get this thing solved. So 33 divided by 3 is 11, and x squared divided by x is x. These 3's will cancel. I'm only left with x squared. And these x squareds are going to cancel. I'm left with minus 12. This screams another quadratic that I can solve by factoring. So I'm going to actually move the x squared this time because it's negative right now. So if I do that, that's going to give me 11x equals negative 12 plus x squared. So now I'm just going to rearrange this to be x squared, okay, and I'm going to subtract the 11x here, so minus 11x, and then minus 12, and this is all equal to 0. So 2 sets of parentheses. I need factors of 12 that get me to 11. a negative 11, which is going to be negative 12 and positive 1. So x minus 12 equals 0 is going to give me the solution of positive 12 after I add 12 to both sides. And x plus 1 equals 0 is going to yield the solution of x equals negative 1. And there you go. That concludes this tutorial.